Hi and welcome to another Type with me. In today's video I want to talk about Vercel AI SDK. We are going to dive a little bit deeper into an example, into a real example that we are creating, and I'm also going to explain you why it's so powerful. So first of all, I want to explain a little bit why it's so powerful. So for the type-safe AI output with structured data, we first define a schema with Zod. So in this example, you see here that we have a production schema with a name, a price, an in-stock, and a category, and some tags. Then we generate structured output. So what we then do is we are going to ask for OpenAI to give us a feedback back. So of course we all love GPT-4o. So we have our model, we have our schema, product schema, and then we have our prompt. And we can then define a detailed prompt, right? And that prompt will return a product schema back. And from that product schema, we can see the raw model response, which is a wireless headphone. It has a price, it has in stock, it has a category, and it has some tags. Then of course with AI SDK and Zod we can validate and parse the output. And for that we can use the data with confidence, and the benefits of course are that it's type safe from prompt to UI. It automatically has runtime validation, fewer errors, better UX, and easier to refactor, right? So multimodal fallback. So AI SDK can automatically try multiple models. If one fails or returns invalid output, it can go to another model. So for one of my websites that I'm now working on, closeby.one, it's a very cool project. We have here a page. This is a mono synthesizer, and for that we have created a sound designer. So that sound designer can actually manipulate certain MIDI CC parameters here on the website, and we can talk a little bit with it. So that's really cool. One of the things is you need to log into the website to get some trial mode, and then we can choose some requests. So what we could do here is we say I would like to have a Miss Kitten baseline. How can we create a sound for that? Then we enter, we ask, the LLM to give us some answers on that, and then here we go. And to capture the driving electroclass bass style typical of Miss Kitten, both oscillators are blended heavily into correct analog distortion, shaped with a tight decay envelope and resonant low pass filter. And then you see here it gives you a little bit of explanation, and then he is telling us which kind of patches he has modified for the circuit mono station. And we can of course then try this out, right? Or say, yeah, well, I wanted to have it a little bit warmer, a little bit cozier, a little bit fast attack. So for example, we could say we want to have it more aggressively. Then you will see here that he has answered it. We have 3 here, and here you see what we asked. Make the sound punchy and aggressive, increase overdrive distortion, shapen the attack, boost filters, resonate slightly, and open up the filter cutoff. So this is a little bit of the experience that you can do within our application. So now let's dive a little bit deeper into the code. So if we go into the package.json, you see here that we have dependencies like at AI-SDK/Google. We have the AI package loaded in, and Zod, right here. This is Zod for our schema validation. So I have here a folder AI, and you have a lot of functions in there right away. But of course, the most important one is this one. It's the prompt template. We have the CC update item schema, where we say, okay, we want to have a CC and a value, right? This one is our MIDI CC, which is the MIDI CC number, and then we need to change that value for that MIDI CC number, and that's what we want to feed into the system, right? And then here we have our AI response schema. So here we can say brief 1-2 sentence, musician focused, blah blah blah, and then here we have our CC updates, right? Then of course here we have our AI response data, and then we have our quick tweak prompts, right? Where we say, hey, we want to make the sound warmer, gently roll off high cutoff frequencies. So here we can distinguish a little bit of the quick tweak prompts that we send to the AI, so that he can indeed look into, okay, which are the different parameters that I can work with, because we are on a page with a specific synth, right? And here you see that CC updates, we can list of CC numbers and their updated values, so we can do a little bit with that as well. And here you see that we have built our system prompt, and here we say, hey, you are an expert synthesizer sound designer, and here I have our synthesizer, and that's our synth name, our available parameters, current parameter values, and then certain instructions, so that the AI knows what the instructions are. So we analyze the user's sound design request, and we select parameters and so on. So this is actually the system prompt that we want to use into our system. Right, if you are going to look into the main function, then you see here we create the generative AI with our API key. Then we have our system prompt, so we build our system prompt, and then we do generate text, where we say, hey, this is the model, Gemini 3.6 Flash. And then here we have our system prompt, and we have our prompt, right? And then we return our output. Generate text will, if we provide it with the right output schema, always an output like this. With here you see CC and value, and so then the front end can start using it. But here you see when it gives an error, you see is rate limit is it rate limit error, and if it's a rate limit error, we give a warning, and then we start using another model, the 3.5 Flash Lite model, and otherwise the Gemini 3.1 Flash Lite model, right? To fall back a little bit and have some kind of rolling fallback system. If we now go a little bit deeper into it, you will see here that we have our index with our different files, and this is our UI, our front-end UI. That's the drawer that you saw. And if we go into the drawer, then you will see here that we have our result, and then with this result we can have a result.explanation, where we have a little bit of an explanation, and then we have our CC updates, which is our updates with a number and a value, and this number and this value we can also display it, right? But we can also tell it to our UI, hey, these are the updates that you need to do. And then here you see handle CC updates, and probably this is one thing that we can do as an output to a higher level component, and then higher level components can then do things with these CC changes, which is great because then you have our drawer on the right side and then you have everything on the left, and your drawer can just expose the output to the complete page, and then the complete page can then again do certain things with the updates that he got from the AI. And you see it's not only a chat that we are doing, but it's also really handling certain things on the page and really being that assistant over that page. And that's very important from a UI UX perspective. I can't clearly say that enough, but I think this gives really the wow, the magical moments that you want, and that I also want within my application. I want people to say, wow, closeby.one is a really great and cool application where I can drive my synths from a web browser. So I hope you enjoyed this video. I hope I inspired you guys to really try this out, because I think really working with the AI SDK of Vercel and then really trying certain things out into your application is really cool. And if you put all your AI development into a separate folder, it makes it more easier to maintain and do things with it. So I hope you enjoyed it. I hope you liked watching it, and I see you in the next one.